time I try to debug my mind, my code's a riddle, you always rewind. You find the errors in every nested loop. Oh, clever llama, master of the code. You solve our mysteries just like I was told. VFDs and VLCs, you know them well. Edging my secrets.
Welcome back to another video. I'm pretty excited about this video. Today I'm going to be showing you how to write code for a flying shear using the basic AMC template. Not only that, I built a demo to help you understand what a flying shear actually is. Let's go look at the demo. Here is the demo I made for you guys of a flying shear. And before we show you the code and how to write your own code for your own flying shear, let me describe all of the parts that are moving here so that people understand. The first part here is the conveyor. Okay? Now, a conveyor basically moves material along it at some given speed. It could be chocolate, it could be straws, it could be plastic, it could be paper, it could be whatever. It doesn't really matter. It could be pipe. The key thing here is that it moves it at a constant speed. Okay? The next part of a flying shear is the knife, which is represented by this light thing. Okay? I'm going to refer to this as a knife, even though it's more like a little flashlight. But basically, what these little green lines represent is that the material is being cut an equal distance apart. Okay? This distance currently is 6 inches. Okay? Now, in order for a flying shear to work appropriately, this knife has to synchronize with the conveyor while it's cutting. If it doesn't, it will damage the material that it's trying to cut and even the knife itself. Let me show you what this might look like from the point of this demo here if it's not synchronized. All right, in the Connect software, I'm going to purposely mess up the ratio between the master and the follower device. In this machine, the conveyor is the master and the knife is the follower. So it is the flying shear that is looking at the conveyor and doing all the work. So right here, you can see back on the demo that it's making big old squares. And that is because the knife is not synchronized to the conveyor belt anymore, and it's also cutting the distance wrong. And that's because it doesn't actually understand the relationship between the conveyor and the knife anymore because I messed up the units inside of the software. Now, you don't have to worry about the units so much. We're not going to talk about it in this video because I covered it in an earlier video on how to set up user units. If you don't know how to do that, please look at that particular video. All right, so let's fix the user units back to the way they're supposed to be. Okay, so here we can see it's nice and synchronized, nice thin line again, and that the distance is back to being 6 inches. Okay? Now, the cool thing about a flying shear is that not only does it synchronize to the material, making sure we get good cuts, we can change the length of the cut. So instead of having 6 inches, we could have 4 inches. But we can also have the conveyor run at multiple speeds. Let's speed up the conveyor to see what it looks like. So I'm going to change the speed of the conveyor from a 2 to a 4. And if we look at the demo, you can see everything is still nice and synchronized. Nice skinny little line, and it's moving twice as fast. Let's go even faster. Okay. All right. As you can see, it's doing a good job synchronizing to the system. And regardless of what speed the conveyor goes, the knife keeps locked onto it. So let me show you the code. Now, before I show you how to write the code, I'm going to just change the cut length just to show you that we can change the cut length. So the first thing we're going to do is I'm going to stop the demo, and I am going to change the cut length. See this cut length right here? I'm going to change it to 4 inches. Now the system is in millimeters, and so I'm actually going to be typing in a millimeter distance, but I'm going to speak in inches for the purpose of this video. Okay, so what has to happen here is I'm going to update the value going into this block down here called load cam normal flying punch fast return. This is the main block that does all the work. And when I send the new data, right, to this block, it's going to calculate a new cam for us, and we can check to see that there are no errors, right, no errors, and all of the values here are positive, which means that the cam that it produced is good, and we can use this cam, okay? So I'm going to tell it to stop updating the cam, and I'm going to enable the demo, and we're going to start the cam. All right. So we can see that it is cutting a 4-inch piece. If we look back here at the demo, you can see this line is closer than it was before. Okay. And if we scope this, this is what that scope looks like. So the red here is the position of the knife, and the yellow is the speed profile. You can see that the negative value is much quicker than the positive value. And so the negative is the return speed. Okay. Now you'll notice that it doesn't look like it's always going exactly the same speed on the return speed. That's because CT scope is pulling kind of slowly, and so it's not getting you an exact representation of what's really going on. But generally you can understand that it's going much faster backwards, as we can see from the demo. See, backwards is quite a bit quicker than forward. Now, the nice thing about our code, this block actually will tell us what the estimated return speed is as a ratio, or actually a scalar. So here you can see it's 4.8. So what this is saying is that the return speed to home is going to be 4.8 times faster than whatever the master is doing. Okay. Now remember, the master is the conveyor belt, so it's going to go 4 times faster backwards than the conveyor. So if we speed up the conveyor, of course, the knife has to go back faster too. Okay. And again, if we change the index cut length back to 6 inches. Okay, let me stop the demo. Now it should be noted that the way this block is written, you can't change the cut length on the fly. You have to stop the knife. You don't have to stop the full system, but at least the knife you have to stop. Okay. So now we're cutting our 6-inch cuts again, and if we go back to the scope, we can see that the profile is quite different. This is the 4-inch cut, this is the 6-inch cut. And you can see that the return speed is quite a bit slower. In fact, it looks about the same speed forward as it does in reverse, or going back, right? A little bit faster going back. And so if we look back here, we can see that it's a little bit faster in the return speed than the normal conveyor belt. Okay, so now the real question for you is, how do I write this code, right? Well, let's do that right now. So I'm going to go offline so you can see how to do this. So the main block we need is load cam normal flying punch fast return. I know it's a weird name, but basically what it's trying to tell you is that it's going to load the cam table in such a way that it's going to be for a flying knife or a flying punch press or something like that. And the method it's going to return back to home is a fast return, which is good because that allows you to cut smaller pieces. Okay. And that block is found right here in this toolbox. Okay. So under POUs, we scroll all the way to here. You'll see it right here. Okay. And you'll see that there's other variations of the same thing, right? There's a normal with synchronized return. You can't do shortcuts with this, but it's an option. And then there are some rigid versions, which we'll discuss in a different video. Okay, but for now, this is your block you're going to use. And we also need to be able to start and stop and start this block. So the other blocks you're going to need is this one here called Start Cam Continuous and Start Cam Single Shot. Now, what this one here does is basically causes the cam to repeat over and over and over again. Just like our demo's been doing today, it's been cutting over and over and over again. But if we wanted to cut it only one time, just a single cut, we could do this and it would just make a single cut. Okay, and of course the motion stop, I have it set so that every time I hit the e-stop button, there's a motion stop command that's been given. But again, all of these are found over here, right? So this start cam is found right here. And the single shot one is found right here. Okay. Now, the big question is how do we get the cam table to actually tell the knife when to cut? Well, the cool thing about cam tables is that there are these indexes. Let me show you. If we come over here to connect, here's the cam table it produced. There's the input, which is the distances for the master device or the conveyor, and the output, which is the distances for the knife. Now, you don't have to know how any of this works because the block does all the work for you. That's pretty cool. But the key thing here is you'll notice that there are these little numbers here, okay? And basically the way this cam table was set up by this block is that cam entry number 2 is when we want to cut the material, okay? So you can look at this parameter right here, 35007, and it will tell us which one of these rows that it's reading, okay? So all I had to do in the code here is write a little equal block and say when the cam segment, okay, that parameter, equals 2, then we want to cut. And then this parameter here, menu 18, parameter 31, inside of connect, I just got it connected to digital output number 2. But it could be connected to a relay or whatever. But that's really all you got to do. So basically you got a block to set up the cam table. You got one line to tell it when the knife needs a cut. And then you got a line to start and a line to stop it. And that is all you need to make a flying shear application, as long as you don't need registration. Now, if you want to do registration, we'll talk about that in another video, but it is possible to dynamically adjust the cam table on the fly. If you have any questions, post them in the comment section below. Thank you for watching. If you enjoyed the video or found it useful, please subscribe and share the video, and I'll see you next time.